Okay, this is Year 13, Pure Chapter 7, Lesson 7. If you haven't watched the other videos in this chapter, you need to look back and watch those as well. We are doing trigonometry and modelling, and we are solving other types of equations using compound or double angle formulae. If you don't know what those things mean, look back at the other videos. Let's crack on. So we've got 3 tan of 2y, lots of tan of y equals 5. Okay, we're going to solve that where y is between 0 to 360 degrees. Well, to deal with that, we really don't like the fact that we've got tan of y and we've got tan of 2y. It's awkward, okay? We really don't like that. So what I'm going to do is I'm going to try to use a double angle formula on tan of 2y. So I'll get 3 lots of 2 tan y over 1 minus tan squared y. Okay, that's what tan of 2y could look like. You can use the double angle formula that's there. Lots of tan y equals 5. Okay, well that thing comes out as 6 tan squared y. So I've multiplied the 3 by the 2 and multiplied the tan y by the tan y. We get 6 tan squared y over 1 minus tan squared y. So try to get it into one fraction if possible. It's technically a one fraction, but one combined fraction. Now we're going to multiply this denominator up by the 5. We're going to multiply both sides by the denominator. Just be really careful here, because you can do the 5 times the 1 pretty obviously, but pretty often people miss off the negative tan squared y times 5. Just watch out for it. So you get 6 tan squared y. As a rule of thumb, whenever you move kind of a denominator made up of 2 terms, just bracket it. It makes it kind of move a little bit more easily. Minus tan squared y. The problem with trig questions is they can look like they're right when they're absolutely totally wrong. So just be double careful with things like that. 5 minus 5 tan squared y. So that was just the expansion. Now we're going to move this term over to the right hand side by adding on 5 tan squared y onto each side, and we'll end up with 11 tan squared y equals 5, which means that tan squared y equals 5 over 11, which means that tan of y equals root of 5 over 11, but be careful, it's plus or minus, which means we're going to get 2 cases. We're going to get case 1, which is when tan of y equals positive 5 over 11, positive root of 5 over 11, and the other one, where case 2, where tan of y equals negative root of 5 over 11. So tan of y equals plus or minus root 5 over 11. So let's try to work out what those things are. We have tan of y equals plus root 5 over 11, which is case 1. And we're going to have a look at tan of y equals negative root 5 over 11 in just a second. Now, what we're going to do with this is we're going to try to keep it nice and tidy. But where we've got this tan of y, it's pretty obvious, you should know this from lower down the school really, that you've got arctan there and root 5 elevenths. Okay, tap that into your calculator. So you get root of 5 over 11, close the brackets, and we end up with 33.9878. My suggestion is to keep quite a few decimal places, and then you can always tidy them up later. So for me, I'm going to go with y is equal to 33.9878. Okay, those will be my first ones. That's my degrees. Now, that is here, 33 point. This is cast, C-A-S and T. So where else, if tan's positive in there, of course it is because everything's positive in there, it's also positive here, okay, which will be 180 added to 33.9878, which is going to be 213.9878 degrees. It makes no sense to go any further than that, okay, up to 393 for example, because y only goes up to 360 degrees. Okay, moving on, we've got y is equal to tan to the negative 1 of negative root 5 over 11. Okay, if you're anything like me, you've probably got root 5 over 11 still on your calculator screen, so I can just put the negative in front. But what happens here is that you get y is equal to negative 33.9878. Now that's no good because it's outside of our domain for y. So 33.9878, negative 33.9878 would be if this is going positive around here, you know, it goes 0, 90, 90 is bigger than 0, up to 180, up to 360, okay, well, negative would go backwards, wouldn't it? Okay, now that is cast C, A, S and T. And in this region here, tan is negative. Well, obviously it is. Okay, we've seen lots and lots of negatives to prove that. Tan is also negative in this quadrant here. Okay, well that's 33.9878. Okay, so we have y being 180 minus 33.9878. Okay, which comes out as 146. 180, pardon me, minus 33.9878 comes out as 146.0122 degrees, and also 360 subtract 33.9878, 360 subtract 33.9878, which comes out as 326.0122, 326.0122 degrees. Okay. Those are your values for y that are actually candidate values. I'm going to round up into 2 decimal places, and I'm going to put them in order as well. So we've got y equals 33.99 degrees, 146.01 degrees, 213.99 degrees, and 326.01 degrees. Okie doke, there we go. Moving on. Show that sine of 3a is equal to all of this stuff. Now, all of this stuff's just got sine a's in it. Okay, it looks complicated, it looks absolutely horrible, but it's just got sine a's in it. Okay, whereas this is actually a bit more annoying than it might be expected to be. What we're going to do is treat it as sine of 2a plus a. Okay, and to do that, treating it as sine of 2a plus a, we're going to be using this compound angle formula is going to be involved. So we're going to have sine of 2a plus a could be expressed as sine of 2a cos of a plus cos of 2a sine of a. Okay, now I want everything as much as possible to have sine of a or sine cubed of a or something like that, but not sine of 2 of a. So the only thing we can do with this double angle formula here, it looks like it's counterproductive because we're going away from having sine of something, but we want lots and lots of sines of things. But it's much worse to have 2 a's than it is to have cos's being involved. So we're going to have 2 sine a cos a lots of cos a. So that's your double angle formula, but all I've got now is a's. That's great, it's not 2 a's, that's handy. Okay, and plus we're going to have cos of 2a, lots of sine of a. Now I can pick what I want for cos of 2a. Okay, now look in here, be careful. If you look, there's cubed coming out. So don't be worried about the fact that you're going to end up with 1 minus sine squared a multiplied by sine of a. Okay, you're going to end up with cubed coming out of it, and that's absolutely fine. So 1 subtract sine, 2 sine squared a, lots of sine of a. Okay, so that's my cosine of 2a form that I've chosen. This one didn't have a choice, this one did, and I went for the one that had sine in it. Okay, next we've got 2 sine a, lots of cos squared a. I'm just going to bracket that because you'll see why in just a second why that's pretty handy. Lots of, plus sine a minus 2 sine cubed a, just an expansion there. Now this here is 1 minus sine squared a. You should know that from year 1. Okay, so 2 sine of a, lots of 1 minus sine squared a squared, plus sine a minus 2 sine cubed a. And they are 2 sine a minus 2 sine cubed a plus sine a minus 2 sine cubed a, and that comes out as 3 sine a minus 4 sine cubed a, which is what I wanted. Okay, I've got it. Good news. Okay, now we can actually use that information, and the way that we're going to use it is, given that this stuff happens, which we've already found, okay, and it might be that a question might have part A, and then it might have hence or otherwise for part B, which means if you can't do part A, you can still have a crack at part B. Solve this stuff. Now, this is strange because this looks like a quadratic. It looks a bit like a quadratic, but the fact is that it's got a cubic there, so it's a bit weird. Obviously, it's also got lots and lots of signs in it, and so that's confusing too. The other thing is that this doesn't seem necessarily to be involved with this. So what I'm going to try to do is to produce this within this complicated looking thing here. Now, to do that, just look at the coefficient of the sine cubes. It's -4. Well, what I'm going to do is I'm going to say, well, there must be something that when I multiply it by -4, it produces 12. So that would be -3. Okay. If I multiply this whole thing by -3, I produce this chunk here. Okay, not including the plus √5, obviously. So we're going to get -4 sine cubed of a plus 3 sine of a. So that's this chunk here produced, plus √5 equals 0. But this thing here is equal to sine of 3a. So we've got -3, lots of sine of 3a, plus √5 equals 0. Sine of 3a equals, well, I'm going to subtract √5 from each side, so move that over and divide through by -3, and I'm going to end up with √5 over 3. Okay, now I'm going to solve this from 0 to 360 for x. I should have put some domains on the question when I made it, but I'm going to go up to that thing. Now, if x goes up to 360, then 3 of x, this is 3 of a I've written, okay, so if we've got 3 of a, okay, would go up to 360 multiplied by 3, which is 1080. Okay, so what we're going to have is we are going to use sine to the -1 on this chunk here. Okay, so we'll have 3a equals sine to the -1 of √5 over 3. Okay, which is going to be sine to the -1 of √5 divided by 3. Close the brackets. Comes out as 48.19. 3a equals 48.19. Okay. By the way, you might be wondering, you know, do I need to include the negative version of this? And in fact, you don't know. Obviously, it went over, became negative, and then divided through by the -3. But the fact is that it's got a positive there at the start. Okay. And so it's implied that it's going to be positive. Okay, it doesn't say plus or minus there, and it's not something that I've rooted to produce it. Okay, so you don't need to worry about that. So we've got 48.19 for sine there, so 48.19, and this is in sine, so C, A, S, and T. S there at 48.19 will be 180, subtract 48.1, 189, blah, 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 blah. So 180, subtract the answer that I just set on my screen. So it will be 131.81. But not only that, this is going up to 1080. Okay, so it's going to do this loop once is 360, twice is 720, 3 times around. Okay, and each time it does it, it's just going to add 360 onto each of those things. And so what I'm going to get is going to be 408.19, 491.81. So that's 360 added onto each of those, and 768.19, and 360 plus 491 plus 0.81, pardon me, plus 360, it comes out as 851.81. Okay, and if 3a equals each of those things, a will equal each of those things divided by 3. Okay, so for example, 48.19 divided by 3, which comes out as 16.06. And you can just divide those things by 3 yourselves. Okay, I don't think you need to see me dividing things by 3 with a calculator. So moving on, your tasks for this lesson are in the Edexcel Year 2 book on exercise 7D, page